Hello everyone. Today's session we are going to discuss one of the most fundamental concepts in AI, namely learning paradigms in artificial intelligence. In this we will understand how machines learn from data, explore different types of learning approaches and examine their real-world applications. So let's begin with the recalling session of previous topic. Artificial intelligence enables machines to perform tasks such as reasoning, learning, and decision making. So AI has evolved tremendously over the years and is now widely used in electrical engineering applications, including predictive maintenance, smart grids, and signal processing. So now an important question arises. How do machines actually learn? So that brings us to learning paradigms in AI. And today's topic for discussion is what AI learning means, supervised learning, unsupervised learning, the challenge of traditional programming versus machine learning, and finally the real-world applications of this learning paradigms. So now let's move on to the defining AI learning. Artificial intelligence refers to the systems that imitate human intelligence and process information to solve problems and make decisions. So learning is one of the most important capabilities of AI. It allows systems to improve their performance continuously based on new data and experiences. Different approaches to training AI systems are called learning paradigms. The major learning paradigms include supervised learning, unsupervised learning, and reinforcement learning. So, understanding these paradigms help us choose the right technique for solving different engineering problems. Now let's see about the supervised learning paradigm. The supervised learning is one of the most commonly used learning methods. In supervised learning, the machine learns from labeled data where every input is associated with a known output. The objective is to establish a relationship between inputs and outputs so that the model can predict outputs for unseen data. So popular algorithms include decision trees, support vector machine, and neural networks. Supervised learning is widely used in image recognition, spam detection, speech recognition, and medical diagnosis. The traditional programming versus machine learning. In traditional programming, humans provide both data and manually coded rules to obtain the desired output. However, in machine learning, we provide data and expected outputs, and the machine automatically learns the rules. This ability to discover patterns from data makes machine learning more flexible and powerful than conventional programming approaches. So, this shift from rule-based system to data-driven learning has revolutionized modern artificial intelligence. Next one is the supervised learning, learning from labeled examples. That is the supervised learning process. The supervised learning process consists of four major stages. First, training the data is collected with known input and output pairs. Second one, appropriate algorithm is selected and training using optimization techniques. Third, the model is evaluated using metrics such as accuracy, precision, and recall to ensure good performance on unseen data. Finally, the trained model is deployed in real-world environments and continuously monitored to maintain performance. Unsupervised learning. The unsupervised learning is used to discovering hidden structures. That is, unsupervised learning works with unlabeled data. Its objective is to discover hidden structures and patterns within the data. One important technique is clustering, which groups similar data points together. Algorithms such as k-means and hierarchical clustering are widely used. Another technique is dimensionality reduction, which compresses high-dimensional data while preserving important information. And also the PCA, principal component analysis, is a popular example. Association rule mining identifies relationship between variables and is commonly used in recommendation systems and market basket analysis. So unsupervised learning is extremely useful in anomaly detection, customer segmentation, and feature extraction. Next, the industrial applications and real-world impact of AI. Learning paradigms have transformed many industries. In autonomous vehicles, reinforcement learning and supervised learning work together to enable intelligent decision making and object detection. In healthcare, deep learning models and analyze X-rays and MRI images with remarkable accuracy, assisting doctors in disease diagnosis. Streaming platforms such as Netflix and Spotify use a combination of unsupervised and supervised learning to understand user preferences and provide personalized recommendations. So these examples demonstrate the tremendous impact of AI in modern society. This is the summary of the learning paradigms at a glance. That is, AI learning paradigms provide different ways for machines to acquire knowledge. One is a supervised, unsupervised, and reinforcement learning. So together these paradigms form the foundation of modern artificial intelligence. Thank you.